So I don't know, maybe this was one of you jokers, but just recently someone emailed me and said that they love some of my screencasts and stuff. At least they thought they did. And then they noticed that I use the word basically all the time, and now they can't watch anything that I say. So I basically just feel like basically all the time I say nothing but basically. I'm incredibly self-conscious about it. Yeah, if you want to ring a little bell every time I say basically, apparently this is a problem. Yeah. Cool.
Oh, there we go.
Yeah, so basically the talk tonight is about descriptors. Starting with me, so I'm Simeon Franklin, and what I said this guy, which is about right, actually. You're a humble co-organizer. I currently work for Twitter. I'm a technical instructor. I teach Python and like some other stuff to people at Twitter. You can follow me on Twitter or find my personal page, SimeonFranklin.com. So I don't know, maybe this would have been a better title. What are descriptors and why do I care? So kind of the idea with the talk tonight is descriptors give us a powerful interface to write reusable code that can be shared between classes. Totally not in an inheritance sense. We'll see what that means. Just if you're working with object-oriented Python code, you need to understand how descriptors work, even if you're not going to write any yourself. And it might turn out that it's useful for you to write some descriptors yourself. So we're going to try and talk through some implementation patterns and anti-patterns and some use cases, as well as explain, again, what the heck descriptors are in the first place. So cool. We'll do some descriptor magic here in just a little bit, but it's going to take me a little bit to get to descriptors. Got just a bit of background knowledge to review first. There's going to be like lots of details. Listening to Jess, like trying to pay attention when it gets detailed. I'll try to go slow with details. I'm having trouble following meta classes. I think this might be easier, but it's worthwhile. Knowledge is power, so let's gain a little bit of power. Everybody knows about simple classes and objects, right? You make a class. It's got some attributes. It's got some functions. This particular thing is kind of interesting. It's got class attributes and object attributes, and everybody's okay with that. I can make an instance of my class, and I can refer to an attribute called pi there on line 9. What exactly is that? So when you access an attribute of an object, so basically you just say, like object.foo. What goes on exactly? So the first thing you get back is something stored in the objects __ dict property, right? Everybody knows that. It's just attribute access is like syntactic sugar for dictionaries, more or less. But of course, if you reference an attribute that doesn't exist on the object, then you fall back to looking in the classes __ dict property, which is also like a dictionary-like thing in this case. So you can say my circle.py, that's not on the object, so it looks in the class. So everybody's there. 3 simple rules for understanding attribute access. You say object.foo, and that means you're getting the foo key out of the dict on the object, or you're getting the foo key out of the dict on the type of the object, i.e. the class of the object, or if you assign to it, you're just creating it in the dictionary. Okay, so 3 simple rules. Attribute access, really, really simple, really easy, really uncomplicated. Throw inheritance into the mix, just to make sure we account for that. So you have method resolution order, class B inherits from class A. I got a couple classes here. And you can say, you make an object and you can reference like the copyright attribute, and it looks through the MRO, the method resolution order. Is it on the object? Is it on the class? Is it on all the classes listed in the MRO, the inheritance chain? Okay, so it actually should be 4 rules. Look in the object dict, look in the class dict, look through all the classes in the MRO. Oh yeah, and if you assign to it, just create something on the object. Okay, so basic Python knowledge, everybody's with me so far. Okay, one more thing here. Before we get to descriptors, sometimes just simple attributes aren't enough. We need something a little bit more powerful. So, here's a classic object-oriented programming mistake. I have this class called circle. You call the constructor, you pass it a radius. Oh, and sometimes people want the circumference, so I'm going to calculate that in my constructor there on line 5 and store it. And I now have a broken class, right? You can change the radius and the circumference doesn't change. So, yeah, I'm stealing from Raymond Hedinger. You can go watch his PyCon talk, and he's got circles and explains this stuff, but steal from the best. So everybody knows how to fix this particular problem, right? It's really beautiful in Python. You say at property, that's a decorator. You write a function that has the name of the attribute you want to intercept, and hey, it's a getter, right? It's a calculated property. It still looks like you're referencing an attribute. You can say my circle.radius is equal to 3, and my circle.circumference, it looks like it's an attribute, but really there's a function call, kind of hidden there. So we added a getter, but we didn't have to change the API of our class at all. Cool, powerful feature. We like properties. I love getting people who write Java and showing them properties, and they're really happy because you don't have to write all your getters and setters up front. You can add them later on when you need them. So property is cool. We like property. Have you ever wondered how the app property decorator works? And is it actually always the right tool for the job? So just review our attribute access rules, which are growing slightly. Okay. 6 simple rules. If you say object.foo, you get the result of the property if it's defined, and I don't really know what that means. Or the value in the object dictionary, or the value in the class, or the value in the inherited classes until you find a match, looking through the MRO, accounting for inheritance there. And assignment always creates a new entry in the dict unless there was a setter property, and we can do both getters and setters with that app property thing. So our rules got slightly more complicated, but everything we know so far. That rule number 1 is actually this rule instead. Accessing an attribute, so saying object.foo, gets you the result of the __ get method of the data descriptor of the same name attached to the class if it exists. That's really what's going on. Yay, descriptors, finally, we got there. Okay, so what is a data descriptor? What's a descriptor? It's easy. A descriptor is just any object that has at least one of 3 methods: get, set, and delete. A data descriptor has both get and set. A non-data descriptor, that's really the name for it, has just get. So, I'm done. Okay, not quite. Thank you. Have I said basically yet, by the way?
No.
Okay. I'm sweating. I'm sweating up here. I'm really working hard not to ever say basically. Okay, so we'll look at the implementation, some ways to implement those 3 functions, like what they mean. But first, you'll hear people talk about the descriptor protocol. So just to kind of clarify, the descriptor protocol is rule number 1 explained, and also a brand new rule number 3, plus a few more details of management. So here's the deal. 7 simple rules. If you say object.foo, what you get back is the get method of the data descriptor that's attached to the class, the type of the object you're referencing if it exists. Or, number 2, you could be retrieving the key from the __ dict attached to the object. Or, number 3, you could be getting the get method of the non-data descriptor. It's like there's 2 different kinds of descriptors, and they both have little slots in these rules. Or you could fall back to looking on the type or the list of inherited types until you find a match. An assignment always creates an entry in your object's dict, unless there was a setter property, which we now know means you're calling the __ set method of the descriptor, which is an object that's attached to your class, and we got to figure out what all that is. Okay, so there's actually 7 things that object.foo could mean, right? This is horrific. No one could possibly understand all this stuff. So many rules, right? It's not that complicated. People do all sorts of really complicated things all the time. Descriptors. So there's this get, set, delete method. Their signatures are fixed, and I want to look at what it means to write these 3 methods. Some common patterns of implementation besides just what the signature looks like. And I'm going to just punt on del, because who wants to delete a property, an attribute anyways? So I'll just do get and set, if you don't mind. Okay, so get and set. My slides look really weird in this resolution. Can I just... There we go. Cool. Descriptors will look really odd because descriptors are instances of an object that's then attached to another class. So this is lines 1 through 5 here is a descriptor class. Any class that implements at least one of __ get, __ set, __ del here. So I've got get and set. And all I'm going to do is print out the arguments that I got. So I'm not going to do anything useful. But you would typically attach this to a class by saying, at class definition time there on line 8, x equals an instance of my descriptor. And that's really weird. That's not really how most stuff tends to work in Python. Usually you make attributes, like in the init on self. And attaching it to the class is a totally different thing. But again, the point of this is to simulate attribute access and kind of hide a function call. So when you make an instance of your class, you can reference object.x, x attached to the object, and what you're really calling is the get method of the instance of the descriptor that's attached to your class. That's what happens. So function calls hidden attached to the class too. You could say myClass.x, and you've got a hidden function call. You're calling the get method of the instance of the descriptor attached to your class. And you can assign to the object. You can't assign to the class. We'll see that in a bit. But again, it's kind of like a property sort of thing, but a lot more complicated so far. So details on the methods. You're going to get self, because you always get self. Self is the instance of the descriptor. So just thinking about this, there's going to be one self for any particular class. Like you made one instance of the descriptor attached to the class. Doesn't matter how many objects you make from the class, there's just one self, one instance of the descriptor. Object is the thing that you're attached to. So the object that you're attached to, that's made from the class that you put yourself on. Type is the class that you're attached to. And get you can call on both the class or the object. Set you can only call on the object, and there's a few obvious reasons for that. Also, if you call on the self and type are both provided on object attribute access, that makes sense. Only type is provided on class attribute access because I think I meant to say object. There is no object that you're attached to if you're calling attached to a class. I think I got an example here that'll make that clear. So this is what our descriptor looks like. And this is me trying to write a useful descriptor. So I could say, what do you usually do in a class? You attach stuff to self, right? This looks like really good, normal Python code. This doesn't work for descriptors. Why not?
Self is the descriptor, not the object.
Self is the descriptor. There's only one descriptor. No matter how many different objects are made from the class that it's attached to. So essentially, we just recreated a class level attribute. You could set your attribute, and then you'll be able to retrieve the current value from another instance of the same class. So you can't do that simple thing. It would be nice. You can't do that simple thing. Possible strategies for how we could write, recipes for how we could write our descriptors. We might try storing stuff on object. So that's the instance of the thing I'm attached to. We could try storing stuff, instance of the class the instance of our descriptor is attached to. Sometimes I have no idea what I'm saying myself. It's really not my fault. It is that complicated. Or maybe instead of attaching stuff to object, we could attach stuff to self. That's the descriptor itself, but we'll have to vary it somehow. So let's look at those strategies, and maybe this will help us understand our get method a little bit better. Let's try storing stuff on self. So here's the problem. You can't just store stuff on self with the same field name. You've got to vary the field name. So what I might try doing is using object, that's the thing that I'm attached to, as a dictionary key. So I'm going to make an empty dictionary in the constructor of my descriptor. When you try to retrieve the value of my descriptor, I say, well, which object am I attached to? And then I'll give you the value for that particular object, right? And the same thing with self. I'm just going to store the value that comes in, and I'm going to use the object as the key. So this is actually really horrible. I actually wrote a descriptor like this, and it has some really strong problems. Among other things, you now have a reference for every instance of your class stored in the descriptor attached to the class. So you can delete the objects. They don't get garbage collected because you've still got a pointer to them, essentially. You'd have to delete the class to make the objects made from the class go away. That's really bad. Shouldn't do that. You could still use the same pattern. Yeah, you could use weak references. So PEP 205, there's a weak ref module. It's got a dictionary that you give it objects to use as keys, and it doesn't use the object. It uses a weak reference to the object. Be careful, because stuff disappears from your dictionary when it gets garbage collected. I can occasionally bite you when you're iterating, but this would work. And some people write descriptors this way. So just make a weak key dictionary. Again, kind of vary stuff by the object as key and store everything in the descriptor. Sort of, kind of. Not everything can be weak referenced. So if you use slots, no weak references. A bunch of the built-in types can't be weak referenced. You can't use lots of things as keys, right? You get the, have you ever tried to use a list as a key to a dictionary? You get the unhashable type thing. So if you inherit from a mutable data type, you can't use. So there's a bunch of classes of things that you won't be able to use as weak reference keys in a dictionary. So we might not be able to use this solution. So let's try storing stuff on the object that a descriptor is attached to. So that would be obj. And here's a problem. You define your descriptor like this, right? You say like val equals an instance of my descriptor class. At class definition time, the descriptor's constructor runs. It doesn't know the name of the attribute that it's attached to. So how do you know like what name should I use on the object? You could do this, right? You could just duplicate the name. You could pass, like hard code the name. Val is equal to my descriptor, and I'll pass you the name of the field in which you can safely store stuff. So just a little bit of code duplication, and it makes the descriptor easy to write. So my new strategy is the constructor for my descriptor assumes you're going to give it a field name. My get just prints you called get, so I can see it happens, and then you're going to store stuff in the objects dictionary with the key self.field. And the set is going to store stuff, the get is going to retrieve stuff, but you're going to use the field name in the objects dictionary. So you get why that works, right? If you say object.x, normally you'd get the stuff stored in the objects dictionary, but since you have a descriptor, you don't. It's kind of hidden. So it's okay if the descriptor uses object.__dict.x. Nobody else is going to be able to get to that value without explicitly referencing the dictionary. So that would be a safe thing to do. The only thing is you've got a little code duplication. And fortunately, that doesn't bug programmers. Like a little duplicated code, it's fine. So nobody cares. That solution works fine. If only I knew something about metaclasses, which I totally don't, or class decorators, you could do something magical to make the pain go away. Like this. You can attach a decorator to a class. It's always easier for me to write than metaclasses, but not quite as powerful. And this is a descriptor that says, give me a class, I'll loop over all the attributes of the class, and I got the name, and I got the thing. If the thing is a descriptor, then let's go ahead and tell the descriptor the name that it's being stored under. So that prevents my little bit of code duplication. Just at the expense of a little bit of magic. It might be too much magic. It does work, it's nice, but I don't know. Your tolerance for magic may vary. So again, the point of all this is you can say like object.x equals 10 and object.x, and you get back a value, and really behind the scenes there are function calls, and this feels like property was cool, right? Does anybody think descriptors are cool so far? Y'all want to go out and write descriptors now, right? Property is actually syntactic sugar on top of the descriptor protocol. It's implemented using descriptors. And so is static method and class method. A bunch of the decorators that do stuff to your class's methods are actually just taking advantage of knowing how the descriptor protocol works. So we might want to understand what's going on underneath the covers. But hey, maybe property is just like doing the typical Python thing, right? It gives me a simple interface to a complicated thing, and cool, I don't have to write custom descriptors because somebody else did that hard work for me. Is there ever a reason for me to go out and write objects with get, set, delete methods and attach them to my classes at runtime and put up with all the pain of implementation? Yes, there is. So app property is not going to work for every case where I need to intercept attribute access. Imagine this use case. You got a class, it's got a bunch of attributes, and they're all going to store currency amounts, and so you want to make sure that they're decimals. You want to do like a little bit of normalization. Well, that's cool. I know properties, so I can just write a separate property definition for every single attribute. Like if I had a dozen attributes and all of them wanted to convert stuff back and forth to decimal, I'd have to copy and paste. It's not very much code, but I'd have to have one of these app property things for every single field, and another one of these setter things for every single field. Like I've got a bunch of repetition there. Just keep repeating. And it kind of seemed to me that the point of app property was to keep me from having to put a bunch of boilerplate in my code in the first place. So I don't want to do that. Wouldn't you rather do this? You could write translate stuff from strings to decimals or from floats to strings to decimals in a descriptor pretty easily. And then you can just signify the fields that have some common behavior at class definition time. That's a lot prettier. I mean, that looks good. I'd rather do that if I could. The takeaway, descriptors are cool if you've got properties that have the same behavior across lots of different names and maybe across lots of different classes. It's like reusable properties. So does that ever happen? Think database fields, and this looks like familiar code, right? You have like varchar fields, and there's some stuff that goes into having a varchar field. You might always want to make sure that the varchar field, the data coming in, isn't longer than the maximum length. Of varchar fields name different things on lots of different classes. So familiar code, for any database ORM layer. And there's some descriptors in Django. GUI languages. You've got properties that need to do stuff when they change their values. Talk to an event loop, tell them something has changed. If you've done a little bit of Kiwi has properties that are really its own hand-rolled descriptor. You might do it just to be cool. Like, it's kind of nice to have a declarative API. It's fun writing forms or models in Django. They all kind of look the same. You make a class, you have a few like class-level instances. We can provide that API if we can write descriptors. Or maybe you just want to do advanced things like your own property decorator. And this is one that I've seen. Zope has this, more or less. Ronaker has one of these. There's one of these like in Flask, I think. It's a lazy loading property. And let's see if we can understand what's going on here. So every framework ever seems to have an implementation of this. The first thing is my lazy property. What kind of descriptor is that? Non-data descriptor, right? You remember, so descriptors have at least one of three methods. Data descriptors have get and set. Non-data descriptors only have get. Okay, so non-data descriptor, and what it does is, that's interesting. My constructor takes a function and stores it, and also remembers what the function's name was. And then my get method says, I'm going to call the function that was passed to me to compute the value. I'm going to stuff it in the object, and I'm going to give you back the value. So you could use it like this. It looks a lot like the property decorator. You just write a function, defx, it returns 42, the answer to every complicated question. And it's decorated with @lazy property. So what is it doing? The first time you reference x, it called the descriptor and gives you 42. The second time, it just gives you 42. Do you remember why?
Storing it is the actual object's dictionary, so it doesn't have to go to the.
We're relying on rule number 3. Rule number 1 is data descriptor. Rule number 2 is in the object's dict. Rule number 3 is non-data descriptor. We hit the non-data descriptor the first time. We put it in the object dict. The second time, we hit the object dict instead of falling down to the non-data descriptor. It's a lot of details. Honestly, writing out the list of rules, I was struggling to keep it all on one slide. But if you get how it works, like, congratulations. This is a complicated piece of Python's object-oriented machinery that's useful. Go forth and wizard. Write cool stuff with it. Some resources you might like. Totally was inspired by Luciano Ramalho's talk at PyCon about descriptors. Made me actually think descriptors could be useful. David Beasley has a cool talk that has some stuff about descriptors in it, among other class magic. Follow me on Twitter, and I will post the slides on my blog here when we get done tonight. Any questions?
Can these properties, I was thinking, be used to make some of the attributes in instances, objects, private, effectively?
Yes.
Similarly,
the descriptor spec says make a data descriptor, and then you're supposed to raise a not implemented. There's a specific exception to raise in the set method, and that is what Python means when it says you have a read-only property. There's also you can raise it in the get to say you could get the value, but you're not allowed to. So yeah, implementing things like data privacy or data prevention is something you should do with descriptors. You could just put a @ property to write the getter and not write a setter too, but you get a more cryptic error message in that case.
Yeah, slots and descriptors.
Slots and descriptors.
So could you describe some useful use cases where these two things go hand in hand?
So I need more rules if I get to slots, because if we have slots, we don't have an underscore dict at all. We've kind of hard-coded what our definition looks like, and we're no longer syntactic shook over a dictionary. A reason to use both slots and descriptors. I can't think of a particular reason to use both. You typically use slots for efficiency, right? And you typically use descriptors for mediated access to properties. The two don't necessarily interfere with each other as long as you're not trying to store references to the particular objects. So I don't see any reason why you can't use both. I can't think of a good reason to use both particularly. I tend to leave off slots if I can manage it. I like my Python dynamic.
So Simeon, I wanted to ask you about the slide. So you brought up kind of increasingly scary use cases of descriptors before switching back to properties. But if we went back to that kind of really scary part, what's really, if we wanted to start using descriptors, where should we be storing the data? What came out to you as the best way of?
So I do like storing it on the object. It's nice to get the field name, and I'm okay with using a class decorator to magically give me the field name. When should you use descriptors? If that was the case, if that was the question, if I have to.
I think you got the when should we use them.
Yeah, if I have to write two properties that look the same, descriptor time.
Right. Yeah, it was just where's a good place to store them? Because when you brought up using a dictionary with keys, I mean the hashable.
Yeah. So it seems like there isn't any perfect always solution, and if you look for descriptor recipes. People use the weak ref. It tends to make sense that descriptor data should be stored in the descriptor. That logically makes sense. But there's some significant drawbacks to that approach. And I personally, when I write them, I always store them on the object with a field of the same name.
Hello? So you showed your examples of showing descriptors for objects as attributes on your classes. In which cases would you want to use a descriptor for a function on a class?
So intercepting access to a function?
Function, yeah.
Yeah.
I've seen that before, but I can't quite remember why they did it.
The normal way we're kind of attaching descriptors is, it kind of looks like fields, and we're thinking about these things as attributes, just pieces of data, and not thinking about them as functions. But that last one that I did, see if I can get to it here, it's important to realize, where's the implementation? Here we go. This @lazyProperty decorator thing is making a descriptor and returning it in place of this function that I made. And then this function x is going to be called by my descriptor. So I am totally replacing a function with a descriptor. And if you're going to do that, the decorator syntax, and decorators are take a callable and give a callable back in its place, seems like the right thing to use. It's extremely common, I might say, to write descriptors and then apply them as function, or apply them as decorators. Cool. So I thought about doing this at the beginning, but I thought I might be too discouraged. Has anybody written descriptors in the audience? Raise a hand. So it's my perception that this is an underutilized feature of the Python language, and maybe it's like metaclasses. There's a lot of details to manage, but I do look at frameworks like Django and see really effective use using descriptors to manage complicated types. So I'm actually kind of encouraged to go out and look for use cases for descriptors. I kind of was hoping I'd do that for you too. Any other questions? Cool.